Welcome to RCR Wireless News. I'm Martha DeGrasse, and I'm here with Steve King. He is an applications engineer at 3M. Steve, it's great to see you again.
Good to see you again too, Martha.
So you told me that your SlimLock is getting the most traction here at the show. So give us a quick overview. I think you've been out with this product for a couple years now, but it's still getting a lot of attention.
Absolutely. So what we're seeing in the industry is a trend towards more dense connection fields on the radios and antennas. So the venerable DIN 716 connector, which we launched the SlimLock closure about 2 years ago for, is being replaced in many applications by the new Mini DIN connector. So you'll notice that this connector body is considerably smaller than the venerable DIN 716. So what we did to respond to this was we worked with the developers of this new connector, and then we sort of in concert with them, we developed a closure that would meet the needs of the new connectors. So these are smaller, as you would imagine, but they use basically the same play on 3M materials, and they have the same value proposition. One-handed operation, very simple to close, and re-enterable closures. So key features that we like to highlight with this is 3M material science. So this is a thermoplastic elastomer bed inside. It's basically it's a gel pad with a non-conforming foam on the edges, so it never takes a set. So this squeezes all the air out when you make the closure, and thereby not trapping any the way perimeter seal closures do.
So some of the research and technology from 3M really informs this product. Can you give us a little bit of the history of how 3M came into wireless infrastructure?
Absolutely. So 3M's been into the wireless infrastructure space for many years with our vinyls and mastic tapes. Later, we brought in cold shrink, which is pre-stretched tubing, and that was a big hit in the industry as well. But then with the advent of FTTA and fiber connectivity going up the tower to feed remote radio units, we began to see a lot more opportunity for us with, for instance, our tower-mounted tower dome terminals. They would provide the fiber connectivity, so the translation from a dense fiber cable to, say, a fiber jumper, or the translation from a multi-conductor power cable through some surge protection devices and that sort of thing, power management, going over to the power jumpers on the radios. And we've seen tremendous interest in these sorts of solutions, especially with the densification process that's going on now.
Yeah, I know that you've put a lot of effort into learning about some of the issues related to the tower loading that goes with this densification. Can you share a little bit of that with us?
Absolutely. So I became quite interested in the densification process and the implications on towers a couple of years ago because I was visiting sites and I was beginning to wonder, well, you know, how much reinforcement can they deliver on these towers, and what's their actual load rating when you put these very heavy mechanisms up at the top of the tower? So now I'm seeing that there's not really always good dialogue between the infrastructure providers on the steel side, who are providing the radio mounts, and the OEMs themselves. So, for instance, the separation may not be adequate to provide adequate airflow for proper cooling, that sort of thing. So you have things at odds a little bit, right? So you have the guys that are doing the steel, and they're trying to get as much up there as they can equipment-wise. But on the other hand, you have the OEMs that are trying to make these devices perform properly in an ambient airflow environment. So these can be at odds, right? Because the guys that are making the steel mounts say, well, let's put them all 3 inches apart. But the fine print on the OEMs might say, you know, we really need a foot separation, that sort of thing. And then, you know, there's implications as well, as you see more and more equipment getting up there about, well, how much more can this tower really sustain? It's got a certain finite life to it. You know, do we need to be really seriously looking at either restructuring this or building on new mounts? Now it's not true for the towers that were built, say, in the last, 5 to 10 years, because they anticipated a lot of this. But when you go back to towers that were built maybe in the PCS go-go days of the 90s, not so much. So I'm following this trend very closely and working with the infrastructure providers as well to try and, once again, minimize the footprint of the infrastructure on the tower. So not add to the problem, but subtract from it.
Right. So give us a little bit of an idea of what kinds of solutions we may be seeing in the future.
Absolutely. So a couple of big issues that come about now in this process is as you densify, particularly in urban areas, these are mainly going to be rooftop deployments, right? And so as you have more and more of these multi-band, multi-carrier overlays, and by that I mean, you know, you'd have a large AT&T Mobility or Verizon, they have spectrum in the AWS band, the LTE band, PCS band. Every one of those is going to have its own antennas and its own radios. So you see this multiplication. And so a trend that you start to see is pushback from the community, the property owners, the municipalities about, well, I don't want to be looking at all this infrastructure. Maybe I'm concerned about health implications. And so we see a lot of big issues with site acquisition, a lot of speculation in that area, but we also see the growth of solutions in camouflage and concealment. And 3M uses material science. You can see right over there an image where we're actually using the film technology to camouflage a small cell site. So we see that more and more now as the sites become more dense, that the infrastructure impact on the local area becomes more of a problem.
Okay, well, I think we're going to go over here in a minute and look at some of these solutions, the camouflage and others. Steve King, Applications Engineer at 3M. Thank you very much.
Thank you, Martha.